Hi everyone, welcome to my channel. My name is Fikret. This video course is designed for those folks who are looking to get started with Apache Spark and Databricks. So Apache Spark is one of the most popular big data technologies nowadays. Not only it's popular, but it's also very powerful and flexible. It's enough to mention that it has multiple languages, which makes it very attractive for many data engineers. So this is mostly practical course where we will start with very basics of Spark, specifically Python version of it, so pyspark, and then we'll gradually move to more advanced topics. At the end, there will be sections where we'll discuss some data engineering challenges and we'll address them using the knowledge learned as part of this course. Let's get started. So here are the topics that I'm going to cover today. We'll start with the overview of Apache Spark, where I'll explain advantages, key concepts of Apache Spark, languages that are available as part of Apache Spark. Then we'll move on to Databricks, where I will show how to get around user interface, how to create compute, import notebooks. As part of this course, I will share a few notebooks, specifically demo notebook as well as exercises notebook in case you are interested to do your own homework. I'll also share files. So I'll explain how to set up your environment so that you could repeat the exercises, demo exercises in your environment. The demo section of this course has two parts. In the first part, we will learn basics of pyspark. And then in the second part, we will apply obtained knowledge to solve common data engineering tasks. So we will start by exploring data frame read-write APIs. So we'll learn how to inspect the file system. Then we'll read structured and semi-structured data into data frame, write it into Delta Lake tables. Next, we're going to discuss column transformations, where I will explain how to control list of columns coming from your data frame. So how to select subset of columns and create calculated columns. And then we'll discuss table transformations, which are very common. So we'll discuss filtering and ordering transformations. The next set of popular transformations are table joins, aggregates, and the windows functions. So we'll learn basics of these transformations. Next, we're going to talk about temporary and global views. So views allows you to build interaction between Python and the SQL. Next, we're going to discuss user-defined functions. So PySpark is a very rich language with many built-in languages, but in many cases you need to create your own functions. So we'll explore different types of functions like Python scalar functions. Then we'll discuss Pandas user-defined functions, or UDFs in short, which are more performant functions. Next, we're going to discuss schema evaluation. So in real-life data engineering scenarios, you often face schema irregularities. So we'll discuss different strategies to address these irregularities. PySpark has few built-in data read and write methods, which allows you to write into Delta Lake tables. However, sometimes you need to have more control over your table structure. So in the next section of the demo, I will explain how you can create tables using SQL DDLs and how to leverage auto-generate functionality in SQL to make some data engineering tasks easier. Next, we're going to discuss Delta APIs. So there are some shortcomings of native PySpark read-write APIs. Specifically, they don't allow you to implement upsert logic easily. So Delta APIs are a great tool to overcome this challenge. In the second part of the demo dedicated to common data engineering challenges. We will first learn how to implement deduplication. Then we'll talk about handling missing value. Next, we're going to discuss time dimension generation techniques using the knowledge we obtained earlier. Schema normalization is another common challenge that you need to learn to handle it. Then we'll talk about time travel feature of Delta Lake. We'll also talk about table clones and table partitions. A quick reminder, if you are new to the channel, please take a moment and subscribe. That will help you to stay in touch with my latest videos. Thank you. Let's get started. So what's Apache Spark and why should you care about that? So Apache Spark is one of the most popular big data technologies nowadays. It's open source tool created by Databricks. Not only it's popular, but it's also very powerful and flexible. So some of the features that's worth to mention, it has tools or methods to process structured and unstructured data. It has API or tools to process batch and real-time streaming data. And great news is that they are very similar. So once you learn, for example, batch APIs, you can easily transition to streaming APIs. So it has SQL analytics feature, which allows you to program on SQL. So this is great news for folks who are comfortable with SQL. Finally, it has data science and the machine learning libraries, which allows you to create machine learning and prediction models. In terms of available languages, so you can use Python flavor of Spark. It's also called pyspark. You can also use R, Scala, or SQL within Databricks. Let me cover few key concepts that are relevant for your understanding of this course. So first of all, let's talk about Delta Lake technology. Delta Lake technology is open source technology created by Databricks. It allows you to treat your Parquet-based files as database. Thanks to logging mechanisms that's created on a Parquet filing, Delta Lake technology creates abstraction layer and allows you to treat your files as database, which essentially allows you to perform updates, deletes, upsert against your flat files. So what's Lakehouse? So Lakehouse is your warehouse built on top of Data Lake. Building warehouse on top of Data Lake gives you advantage of having not only structured information, but also semi-structured or unstructured data all in one place. Essential part of Lakehouse architecture is so-called medallion architecture, where you create 3 data maturity zones. So it's called bronze, silver, and gold, with bronze being the first layer of data which will receive the data from your source systems. So that's where your data will land as is. And then you have silver zone, which represents cleans and enriched data. And finally, gold layer, which contains cleans and aggregated data ready for reporting consumption. So Spark is based on distributed compute technology. So the way it works, you create a cluster with multiple nodes, and any task that you submit for Spark is divided into smaller pieces in terms of compute and the data, and then distributed among these nodes. So these nodes work in parallel, and then once your task is resolved, everything is returned to you as a single piece. Spark session. So Spark session is another important concept. So it represents programming entry to Spark. Basically, it contains application relevant configuration settings. You can either create it explicitly within your notebooks. That will allow you to assign some of the configuration settings like application name, application configuration, and so on and so forth. But you can also use Spark session variable in your Databricks. So that's available. You don't need to explicitly create it if you are looking for just basic properties of Spark session. Data frames. So data frames are programmatic representation of your data. So it's a structured object. So data frames will be main programming construct that will be working throughout that course. It's worth to mention that data frames are immutable, which means that any transformations that are applied to data frames do not change state of data frame itself. So you have to assign change data frame to another data frame so that you can materialize these changes. Now that we know basics, let's jump onto Databricks, where I'll show you the basics of UI as well as how to set up your environment for this course. For the purpose of this demo, you will need to have few components. First of all, you need to sign up for Workplace. In case you don't have Workplace, you can sign up for Community Edition. I'll share the link for that so that you could sign up. Then you'll need to have code and the data and the compute. So let me start with compute. So you can navigate to compute node here and use create compute button. And from here, you can select your clusters configuration. So for the purpose of this demo, you can use single node, so that will save some cost. And then you don't need to have photon acceleration because we will be dealing with light workloads here. You can choose any versions of Spark. The code should work with any of them. Once you have specified your configuration, click create compute and it will create personal cluster for you. So that's one option. You can also use serverless option, which I'm going to use during the demo. Advantage of that approach is that, of course, it's faster, so it starts almost instantly, so you don't need to wait for cluster start. Okay, now let's talk about data. As part of course, I'm going to share a couple of CSV files and a JSON file. Once you download it to computer, you can navigate to catalog, select browse dbfs, and upload it to one of these folders. So in my case, I have uploaded into file store folder, and you can use upload button for that. Once you have uploaded the files, you click here and use copy path button and put it somewhere in your notebook so that we'll use this path a little later. Now let's talk about the code. You will receive few notebooks as part of this course. So you can navigate to workspace here and navigate to the folder where you want to place these notebooks. So for example, you can come here and under your user account, you can click import button here, and then you can navigate to your local folder where you will find where you can specify DBC file that you can download from my repo. Once you upload the files, you will see following notebooks. So let me start with exercise notebook. I don't have any code here, but I have instructions here. So this is kind of homework based on the same data files. And if you choose to do that, it will definitely help you solidify the theoretical knowledge that you have received from demo session. So let me come back to demo. So this notebooks has multiple sections. I'll show you a little later how to navigate it. But important things to know is that there's few settings here that you need to localize according to your settings. Number one, this folder needs to point to the root folder where your data files will be located. So if you will upload the files to file store folder just like I did, then you don't need to change anything. Otherwise, make sure that you change this entry here, as well as and so you will see this variable repeated in multiple places. You will need to change that as well. Table path. So during the course, we'll be writing the data into Delta Lake tables. And here you have two options. So you can either write it into Hive meta store, which I am doing within this notebook. So Hive meta store is available in all the workspaces. So this is default storage for Databricks. And within Hive meta store, you can create schema where to upload it. So currently I'm using default schema, but if needed, you can change it to other schema, providing that schema exists. Alternatively, you can write it into Unity catalog if you have one. And in that case, you will need to specify catalog and schema name as well here. Just like with other variable, so you will see this variable settings in multiple places in notebook. So make sure that you change all of them so that your notebook runs smoothly. Here's some other helpful information. You probably have noticed here the language of my notebook is Python. You can select any of these available languages when you are creating a notebook. But because my demo is about PySpark, I have selected Python notebook. However, you will see through the notebooks that I am switching to different languages. And to do that, I use language magics. So here's one magic. So anything that starts with percentage symbol is a magic. So in this case, this is file system magic, allowing you to explore file system. So more about that you'll hear a little later. And similarly, in some other places you will find SQL language, which allows you to submit SQL related command within this notebook. All right, now that we know how to set up environment and how to navigate Databricks UI, let's jump into the demo. Now that we have uploaded the data and created compute, let's start by connecting to the compute. So I have selected serverless, but you can run this notebook using your personal cluster as well. So this notebook has multiple sections, and the easiest way to navigate through the sections is to use table of content button. Here you can jump into any sections directly. So let me go back and hide this section. So let's start by exploring the file system, because that's one of the first skills that you need to have when you are ingesting data. So there are a couple of ways to explore the file system. My first command here is using fsmagic. So fsmagic allows to run multiple file system commands, including list commands that you can see here. So list command allows you to see the content of the folder, but there are some other commands like browsing the file content, creating folders, and moving files to copying the files, and so on and so forth. Some of them we will explore shortly. The alternative way of exploring file system is to use dbutils fs command. Just like with the previous command, I am using ls method here. And you can see that output of this tool is slightly different. So in this case, it's list rather than dataset. Now that we have our files path, let's start by ingesting the sales data, which is in CSV format. So we can take path from here, but in my case, I'm using variable, Python variable, so that it will be easier for you to reconfigure the file path. So my next command here is using read API, and the command starts by Spark session. So again, Spark session is a session variable that available for you anywhere within your Spark notebooks, so you don't need to explicitly create it. Although you can create it if you want to have more control over your Spark applications by attaching certain properties. Notice that we are using chain of transformations or methods in this command. So my read API is followed by a format method, which allows you to specify files format. So in this case, it's CSV. And then I'm using load method to specify exact location of the file. Once I have created data frame, I can use display command to browse the content of this data frame. Let's take a look at the output of this command. So first thing to notice is that Spark has auto-assigned column names to data frame, although my first row contains column headers. So we'll fix this problem shortly. Another problem here is related to the data types. So notice these little icons at the top of each column. This indicates data types for these columns. So if you hover on this, it will tell you exact types. And when you are reading from CSV, by default, Spark assigns string data type to all columns. There are ways to change this as well, which we'll see shortly. Now that we have created data frame, we can browse its structure using print schema method. Output of print schema is in list format, which contains column headers and the data types. All right, so my next command is similar to what we have seen, except I have multiple option methods here. So my first option method tells to use the first row as a column headers. And then I am asking to infer the schema, which allows you to infer data types in your data frame by inspecting available data in your source. And then I specify delimiter for the file. So in this case, I am using comma as a delimiter, but as you may know, CSV files may have different delimiters types as well. So here is my result. Now we can see that Spark uses the first row values as my column names, and my data types are now correct. Ingesting raw files by using infer schema method is a quick and a dirty method of ingesting data. However, it's not the best and scalable way of ingesting, especially if you are dealing with many different files, because for each files we are forcing Spark to figure out a schema. A better and a more performant way of doing that is to specify expected schema. So my next command creates schema variable here, where I specify each column and the data type. And then I am using this variable in my schema method right here. So output result is similar to what we have seen earlier. Once we have created a data frame, the next logical step is to write into delta table. The write APIs have similar structure to read APIs, but it starts with data frames that you want to write to. So in this case, I apply a write API to my DFS data frame, and then I tell it expected target format. So in this case, it's going to be delta. The mode method allows you to specify write mode. By default, it's append, meaning that the data from data frames will be added to the end of your table. However, you can also override target table, which we'll see shortly. Finally, my command is ended with save as method, which specified table's fully qualified name. Alternative ways of writing the table is to use save method here. For save method, you need to specify file locations for your table. All right, now that we have learned how to write your data frame into tables, let's take a look at how we can read from delta tables. There are a couple of ways of reading delta tables. So this is probably the simplest way, where I use table method alongside with fully qualified table name. The alternative way of ingesting from delta table is to use SQL method. This is more flexible method, of course, because you can specify any SQL query that's available within the Spark SQL. Spark SQL flavor is slightly different than, for example, T-SQL. By using SQL method, you can execute not only the read queries, but pretty much any kind of queries, including DDLs, so create table statements, or DML queries. Okay, now that we have data in our delta tables, let's take a look at some ways of exploring this table properties. So describe table command allows you to examine the table structure along with some important table properties. So in this case, let's take a look at the results. So in this case, I'm using extend. You can use describe table as a simple command alongside with the table name, which will bring you only table structure, but with extended keyword added here, you can see some important table properties like table creation time, table location, so on and so forth. Another way of running SQL commands directly from your notebook is to use SQL Magic. So in this example, I use SQL Magic to run the same SQL command I showed a little earlier. In other words, using SQL Magic allows you to combine language snippets from different languages within the same notebook. All right, now that we know how to ingest structured data, let's take a look at semi-structured data ingestion methods. So my next command here uses dbutils command. However, in this case, I'm using head method to inspect file content. In this case, it's JSON files representing product data. Like with CSV ingestion, you can ask Spark to infer its structure by using Infer Schema option. Each data source type has its specific ingestion options alongside with common ingestion options. So in this case, I am using multi-line option for JSON, which specifies type of JSON that I am dealing with. So here is my output. One thing to notice is that one of the columns has complex data type. In this case, category column is object type with different elements like furniture type, room type, and so on and so forth. Just like with CSV files, you can be more specific in terms of expected schema when you are dealing with JSON files. So in this case, I have created JSON schema variable, and unlike with the previous example, I'm using StructType library objects to specify my structure. So StructType alongside with StructField is a part of pyspark SQL types library, which you have to import whenever you are using it. So this command basically specifies array of column lists, and within this array, each element represents a column with its name, type, and so on and so forth. So notice that one of my columns here is a nested column type. So in this case, you can see we have struct field named category, and then we have nested structure information within that. Output from this dataset looks similar to what we have seen. And my next command writes data frame to the table named product bronze. One thing to notice in this command is that I use overwrite mode when writing the target table, because when you are writing dimension type of tables, it makes sense to either overwrite them or use upsert method, which we are going to explore a little later. All right, now that we have learned basic operations with data frame, let's explore some transformations. The first transformations type we are going to explore column transformations. So in command 29, I demonstrate how to narrow down list of columns coming from source. And I use select method for that. The select method requires a list of columns that you want to bring, and optionally you can apply certain SQL functions on some of the columns. So for example, here I use call function, which is one of the native SQL functions, to bring sales amount column values. And then I use alias method to rename this column. There are lots of helpful SQL functions that you can use as expressions, and we'll explore some of this a little later. But whenever you are using SQL functions, make sure that you are importing them like this. Select transformation works like select list, and if you are familiar with SQL, you know that with select list you can either bring columns as is or apply certain functions or transformation on them. The alternative way of narrowing down columns from data frame is select method, and it works similar way to select method, but you can see that its syntax is slightly different. So here, for example, I use as expression to indicate aliases for columns, and I can use SQL functions direct within column definition. For example, the cast function that you can see here is one of the common ways to change data type. So this expression takes price column and converts its data type to decimal. Similarly, I use round function here to round down results of mathematical expression. So in this case, I calculate tax amount by multiplying sales amount to a certain value. Here is another useful function. So this expression, metadata file name, allows you to bring file name as metadata to your data frame. So this is often useful to provide data lineage. So let's take a look at the output. So here I have source file name, and here we have tax amount I have calculated. Another way of narrowing down column lists from your data frame is to use drop function. Drop function, as the name implies, simply drops a list of columns that you provide in the argument from your data frame. So for example, here I dropped client name column from my data frame. The column level transformations that I have demonstrated earlier, they are imitating SQL syntax in one way or another. However, there are some methods which allow you to add calculated columns which have little different syntax in PySpark. So here in command 34, I use a withColumn method to add calculated columns to my data frame. withColumn requires two arguments. The first one is to indicate the resulting column name, whereas the second argument will represent the expressions that you use to get this column. You can use SQL functions that we have seen examples of as part of your expression. So in this case, I am using round function to round down results of multiplication of sales amount. Notice that I am referring to sales amount column through data frame dot column name notation, just like this. But there are some other ways of referring to your column values from within withColumn method. So for example, here I am using call function, which we already discussed, to get sales amount, and then I apply cast data type transformations on top of that. Another useful SQL function is lead function. It allows to attach a fixed string to all of your rows. So for example, here I want to add this string, fixed string, to all my rows. This could often be useful to provide data source names or any useful metadata that you want to include in your data results. Another useful SQL function that's worth of discussion is monotonical increasing ID function. It allows you to generate sequential numbers, which can be used to generate identity columns. So in this example, I use it to generate row ID column with sequential numbers. When building your transformation, you often need conditional type of expressions. And one of the common transformations in that category is if-else type of transformations. So the when function that I have provided as a last transformation in this data frame is conditional. It checks for product name column for certain fixed value. And if product name equals to bad, then it will produce one value. Otherwise, it will produce another value. Of course, you can use more complicated version of this expression with multiple chains. Here I just brought a simple example. I'd like to wrap up column level transformation topic with another demo which explains how you can parse semi-structured data. Earlier, we have ingested product information, and one of the columns this table had was complex type. So we had sub-column names here on the category column. So let's see how we can easily extract different parts of this column using SQL expressions. The command 36 extracts furniture type and the room type from category column, and to do that I can use columns names dot subpart. All right, another common transformation category on data frames are table level transformations. And as a first exercise, let's take a look at filters. The filters allows you narrow down rows based on some conditions. So in this example, in command 40, I use filter method, and my condition checks if product name is bad, and I have additional condition on top of that which checks if the price of this product above $100. Alternative way of applying filters is to use where clause, which works a similar way. There are some common filtering conditions that it's good to know. So if I scroll down to command 42, here my data frame checks for null condition, and to do that I use isNotNull method, which you can apply on top of call SQL function. There is opposite expression for that, which is called isNull, which you can use to bring only empty values on certain columns. Another useful filtering expression is isIn function. So in this example, I check if my product name is one of these values supplied within the brackets. If you're coming from SQL world, you're probably already wondering if there is conditions which will be similar to like condition in SQL filtering. And indeed, there is a like method here, which you can use to find similarities with some string patterns. And so in this case, I am trying to find all the rows for which product name starts with BE strings. I'm going to wrap up filtering topic with another useful expression, which allows you to exclude the rows matching certain conditions. So in command 45, I am using isIn expression to find all the product with the name of bed and the chair. But if you notice here, I have this tilde expression, which tells Spark to exclude all of the rows matching this condition. So as a result, I have all the rows from my source data except the ones which match this condition. All right, let's move on to explore another category of transformations, which is ordering results. So that's another frequent transformation type. And you can achieve that using order by method. So this method is straightforward. All you need is to list columns And optionally, you can specify ascending or descending keywords. So by default, if you don't specify ascending keyword, the ordering will be in ascending order. So in this example, I order my dataset by product name and sales amount in descending order. Now let's talk about table joins. The table joins requires at least 2 data frames. And to do that, you apply join method on one of the data frames and specify another data frame as an argument. You also need to specify a column on which you want to join, as well as join type. So by default, join will be inner join, but in this case, I am specifying left join type. So this is relatively simple syntax for join, and it's applicable when the columns you are joining on has the same name from both sides. So in my example, both product and the sales table have a column name product name. That's why I can use this simple syntax. So let's run this command, and here's the output where you can see columns from both sides. It's important to mention that when you are joining, sometimes you may end up with same column names, especially in the cases when you have same column name from both data frames. To avoid multiple columns with the same name, it's recommended that you apply subsequent select transformation, where you specify which columns from which data frame side you want to output. So in this case, I bring number of columns from sales table, and you can see that some columns like room type and the color are coming from product data frame side. Sometimes columns that you are joining on may not have the same name from both sides. In that case, you can use slightly complicated version of join condition like this, where you specify left part of the join column and the right part of the column with equality in between. The next type of table level transformation I'd like to discuss today is aggregates. Aggregates are very common, especially in the warehousing scenarios where you want to calculate sums, averages, and some other statistical expressions. Just like with other type of transformations, with aggregates you have multiple ways of achieving aggregations. So one of the simplest methods is to use syntax like this, where you add aggregation function to your data frame. So in this case, I am calculating number of rows, which is a very common way of estimating the size of your data frame. The downside of this approach is that not all aggregate functions are available to apply this way. So my next command, command 54, shows how you can use agg method to calculate multiple aggregates. As argument, you can specify multiple aggregates on different columns. So in this case, I am counting number of distinct names on product name, and I calculate total sales amount and the total quantity. Notice that I also use alias column, and if you don't specify this, you may end up with some weird column names. Now, this aggregate we have considered so far, they work on entire table level, but in real life cases, you often need to first group by your rows on certain criteria. So in other words, to slice on certain column before applying aggregates. That's what my command 55 does. So you can see that I first apply group by method, and I say group by product name, and then I apply sum function on top of that. So let me show the results. So in this example, I used simple syntax by applying sum. You can also use average or some other aggregate functions. And this kind of syntax is useful when you are calculating only one aggregate. In more complex cases, when you need to calculate multiple aggregates simultaneously, this syntax demonstrated in command 56 is more useful, where you first apply group by, followed by ag function, where you can list multiple aggregations functions like we discussed earlier. All right, let's move on to window functions, because that's another type of helpful transformations on Spark data frames. Windowing functions are useful in scenarios when you want to divide your data into multiple groups and apply certain transformation to each group. Command 59 in my notebook demonstrates how to do that. So I'm using withColumn method here to create a row ID column, and I use row number function, which is a SQL function. However, this row number function is applied on different sections of the data called window. So here's my definition of the window. So in this case, I use partition by method of window object or window expression to specify column name by which you want to partition your data first or slice your data first. Then within each group, I assign row numbers. Notice that I also use order by, because once you divided your rows within into different groups or windows, then you need to be specific about how you want to order these rows. So here's the result. So in my example, I created window or section of the data for each product name, and within each product name, I have numbered the rows based on sales amount value. Windowing functions allow you to apply ranking or row numbering functions on top of your data slices. You can also apply some useful functions like lag or lead, which allows you to get values from your previous or subsequent rows. So in this example, in command 60, I applied 3 windowing functions with similar partitioning and order by clauses. So you can see that I partitioned by product name and I ordered by sales amount. However, in the first case, I use row number function to number my rows. In the second case, I use lag function to bring the value of sales amount from previous row. So notice that my second argument tells how far back the row should be brought from. So in this case, it's just previous value. And the second expression use lead function to get value of sales amount from the next row. So the lag and the lead functions are very good on calculating some financial expressions. For example, to compare your current year to previous year or next year, and so on and so forth. So basically create comparative analysis reports. So let's take a look at the results. So if we take a look here, so this is my sales amount, and the value of my previous sales is 58, which match to this value. So and my next sales is 60. So my data is not great to demonstrate the differences, but hopefully you get that. All right, let's move on to temporary global views topic. When you are applying transformations in PySpark, there's often need to temporarily materialize your results. That could be helpful from multiple sides. One, if you are chaining multiple transformations, sometimes it's easier to assign certain names so that you could easily call it. And the second, materializing allows you to refer to your data frame values from SQL. So let me demonstrate that in command 63. To create temporary view, you can use create or replace temporary view method with the name of views that you want to create. And once you do that, now this object becomes available from SQL. So in this example, I can select from this view just like from any other table. So this is what you can see as a result. Keep in mind that temporary views are transit objects. They are available only within your session, within the scope of this particular notebook it was created from. So once this notebook's execution completes and this notebook is detached, these objects are no longer available. If you want your view to be referred from other notebooks that are part of the same cluster, you can use create or replace global temp view method. However, keep in mind that it will not work if you are using serverless compute. So in my case, as you can see, it failed. But if you are using personal cluster, you should be able to create a global view and refer to that from different notebooks, as long as the notebook that creates it still attached to the cluster and alive. So this kind of views are not permanent views either. If you want to create permanent views that will survive your cluster shutdown, then you need to create views using SQL syntax. I don't have here, but so you can use create view, specify name, and then you specify your select statement as part of SQL statement. And if you follow that path, then your views will be created as permanent object within your data store, so whether it's a Hive store or a Unity catalog, and then you can refer to them anytime. So let's talk about functions. So far we have been using native built-in functions, but in PySpark you can also create your own custom functions as well. There are many different types of functions available in PySpark. So let me start by a generic Python function that you can see in command 67. So let me run this. So what this function does, it just receives certain arguments like format, path, for example, and then it just uses standard read API format to read from specified path and specified format. So, and here you can see an example of using that function. One of the common ways of using this kind of syntax is that you can basically design transformations, generic transformations within your function. You can have data frame as one of the arguments and basically apply this transformation within your function. And then you can pass different data frames to this function to perform same type of transformations on different data sets. So to recap, this kind of Python functions allows you to apply common logic on entire data frame level, but there are some other functions which work on column level. So if I scroll down to command 68, I have example of a function called tax UDF, which takes price and quantity variables and multiplies them to get a tax amount. So this is scalar function. This is also called Python UDFs, and notice that I am using UDF decorator for that. Alternatively, I can also specify data types that this function expects in the bracket. And once you define your scalar function, you can use this function as part of your expressions, just like this, where I use tax UDF on top of price and quantity columns. Here is the result of this calculation. It's important to know that Python functions designed this way are not recommended, especially if you have large amount of data to apply this function, because these transformations are applied on a row by row basis, which is not very performant way of doing things in Spark. Let's take a look at other types of custom functions which are more performant. So here I am using same Python function with UDF decorator. However, I use arrow keyword, which allows you to leverage Apache arrow technology With this extra keyword, you still get row by row processing. However, your performance becomes slightly faster due to the advanced capabilities of Apache Arrow. So if I run this, you may not notice performance difference. So let's take a quick comparison. Given that my dataset is really small, so if in the first case I had around 9 seconds execution time, here I got 10 seconds, but you will see some performance improvement if you are using much larger data sets. So again, this is still not best way of using UDFs because of its row by row processing nature. Now let's take a look at different types of functions called Pandas functions, Pandas UDF. Pandas UDFs can be different depending on the way we are passing arguments to that. So here's a first example. So it's called series to series. So declaration of these functions is similar to Python function, except I specify a Pandas UDF here. And I say my argument is expected to be float type. However, here's the biggest difference. So I have a first argument where I say my argument type is Pandas series type. My second argument is Pandas series. And I also specifically say my output data is Pandas series. So series is nothing but number of rows. The definition of the function is similar to what we have seen with the Python function. However, this small difference in the way of defining function makes big difference in terms of performance. Because instead of passing one row at a time, we are passing batch of rows from data frames. So, usage of this function is similar to usage of Python functions. You simply use that within withColumn transformation, and you just specify the function name and provide arguments. So as you can see, by simply reshaping this function and changing the decorator type, we can achieve more performance, more scalability and performance. So if I scroll down to see the results, you can see that this operation has completed in less than 2 seconds, which is much lower than the Python function calls that we have seen earlier. So far, we have considered functions where the nature of your transformations are batch transformations. Here, for example, we simply multiply 2 columns together. However, in some cases, you need to have row by row processing logic in place. Examples could be maybe calling some API for each row in your data set, or maybe applying some string transformations on each string coming from your data frame, right? So in these cases, you can use iterator of series to iterator of series type of Pandas function. So here I have example in command 72. There are a few differences in compared to series Pandas function. So in this case, my argument is iterator type, which works on Pandas series. My output is iterator type as well. That means that I can refer to this argument as some kind of list or iterator. So this is what I am doing within this function. Basically, I go over each row within this iterator and I apply certain logic. So in my case, this logic is simple, and of course I could use batch logic. But again, in some cases, this batch logic is simply impossible. Another good argument in favor of this type of Pandas UDF is that if you want to do certain operation before you go over your iteration. So for example, you might want to have some initialization here, some operation here, which needs to be applied for all rows. So you can do that upfront before your iteration starts, and then use this value or calculated state here in your calculation logic. In terms of referring to this kind of function, as you can see, there is not much difference. So we are calling it as part of withColumn transformation, just like we did for other type of UDFs. Another more complex variation of iterators to iterator mapping Pandas UDF is called multiple iterators. In command 73, I have example of functions where I have more than one iterator arguments. To do that, I am using tuple element, and I specify number of Pandas series that needs to be supplied. So in this case, I'm expecting 2 columns here as part of this tuple. And here's an example of transformations that we can place within this kind of function. So let's continue our discussion with group mapping functions. These Pandas functions are great for aggregations type, where you want to slice your data by certain grouping criteria and then apply a certain transformation logic for each group. I have an example of such function in command 74, where I am applying group by on top of my data frame. So in this case, I am grouping my dataset by product name. And then I use applyInPandas function to call my custom function. So here's a definition of my custom function where I perform some aggregations on top of data frame that I receive as part of argument. And so you can see that in this case, my custom aggregation simply takes a list of client names and then for the same product name, and just concatenates them together. So to achieve that, I'm using pandas lambda x and the list functions here. And here's the results. So for each product name, I have aggregated all my unique client names in the client name column. Notice that I am using Schema argument to refer to this kind of functions, where I specify schema of my output data frame. So in this case, it's product name as a string type and client name as array type. To recap, by using applyInPandas construct, you can squeeze your data sets. So in other words, you can take larger data sets and apply a certain transformation and make it smaller. Sometimes you also need to achieve opposite effect when you need to produce more rows from your data sets. So let me show another example where I use mapInPandas function. So this is my command 75. But here I use the data frame created in the previous step, which is aggregate, to get detailed data set. I have row by row iteration, where for each row I apply explode function on client name columns to get all these values in separate rows. So here's the results. So as you can see, my data has returned to its previous shape. Schema evolution. When we learned reading and writing into data frames, you may remember that we have created schema, target schema. So you can do it either implicitly or explicitly. Either way, you end up with a fixed table structure. As long as your data source comes in with the same structure, you can keep adding data to this table. However, in real life, sometimes you get schema irregularities or deviations from expected target schema. For example, you have 10 columns in your target table, but one day you may discover that your data source contains more columns. By default, if you try to ingest your source data frame with different schema to your target, it should fail. So let me demonstrate that to you. So in this example, in command 78, I read from product silver table. I read only one column, the product name column, and write in the product silver 2 table. Yeah, and in next command, I select multiple columns, and I am trying to write in the same target table. let's see what happens. So as you can see, Spark complains about schema mismatch and fails. So this is good mechanism to control your target table schema. And in many use cases, it's desirable to keep ingestion logic like that. However, in some cases, you may want to allow some flexibility. So if you are expecting your data source to change over time, you may deliberately allow automatic schema change over time, which is called schema evolution. So let's see how you can do that. In command 80, I am using the same write command. However, this time I specify merge schema option as a true. And as a result, my write succeeds. And as you can see, the pre-existing rows for these columns, these extra columns are filled with nulls. Here are the new rows that I just inserted. I should also mention that there is pros and cons of this approach as well. So by allowing flexibility, you may also face some undesirable scenarios when your table schema change without your knowledge, which may impact your downstream data processes. All right, so so far in this course, we have learned writing into delta tables by creating data frames. So I would call it implicit table creation, where you don't create the tables beforehand. So tables are created as a result of your data frame writes, which is okay for many scenarios. However, in sometimes you want to have more control over table structure, and this may come with some additional benefits. To do that, you can use power of Spark SQL. So here in command 84, I have created a create table statement for one table, and then I invoke this command to create this table. So a few things to note about this table definition. In this case, I also use some unusual column types. So for example, product ID column here is defined as generated by default as identity. So what this means is that values for this column will be auto-generated with sequential number, which is very handy way of generating identity columns. Here I have another example. This time I use generated always expression, and here I am using concatenation of two other column names. So basically I tell concatenate room type and furniture type. Likewise, you don't need to fill this column as well. It will be auto-populated. So to demonstrate that, I have data frame read from product silver table. Originally I had this product ID column here, but for the purpose of this ingestion, I don't need that. So I have dropped this column here. Let's take a close look at the structure of this data. So as you can see, I don't have this extra columns for product ID and the product category. And once I have run this command and have my table in place, what I can do is just to simply write into this table. So you can see my table, target table name. So let's try to write it. And then I'm gonna browse the content of this table. So as you can see, product ID was auto-generated for us, and we have product category column, which was auto-populated based on two other columns. Okay, so let's talk about other ingestion methods, which allows us greater control over ingestion process. So far, we have used data frames to write into target delta tables, and we use save and save as methods to write. I also explained that there are a couple of different options like append and override. However, in many cases, these options are not enough to control data in your target tables. Examples could be having upsert logic, which is very common, especially in data warehouses. So let me demonstrate that on the example of product data. So here I'm going to read CSV data from product data, JSON file. Let's take a look at command 90. So here I'm using slightly different method of creating target table data frame. It's actually not data frame, it's a little different. So in this case, I'm using Delta APIs directly rather than using pyspark. And once I have Delta table object, I apply 4 paths to specify location of my table. Notice that this location is not in the form of ordinary table path where you specify your catalog and the table, so you actually need to specify actual location of the table. And we can use 2df method alongside with display to show the content of this Delta API object. So it looks like normal data frame object. However, once you create this Delta API, you can apply certain commands which are not part of your normal pyspark library. So examples is update statement, where you can specify your condition, so basically which rows to apply update to, and you can tell what to update to as part of your set option. So in this case, I am telling to update color column with the values of white for all rows which have chair type of product name. So if I run this, if I display back my data frame, the color of these 2 products have changed. Another useful command is delete command, which allows you to delete certain rows from your target table. And its usage is straightforward. So all you need is just to specify conditions for rows that you want to delete. One of the very useful commands when it comes to ingestion is upsert logic. So if you are familiar with SQL, in many SQL flavors, you would have merge into command, which allows you to compare your source and the target, and inserts rows that are missing from your target and updates the ones which already exist there. You can apply merge command to your Delta object like this. So in command 93, I have very simple example of this. So let me walk you through this command. So here I'm taking this Delta object created based on my target table, apply merge command on that. Notice that I'm creating alias for this table for simple reference. Then I include data frames that I consider as a source for this merge command. So this data frame is just ordinary pyspark data frame. So one that I created here. Once I specify source and the destination, next necessary component is a condition. Here I am telling use the product name column to compare my source and the destination. And when I find match, I update all the columns in the target with the values coming from source. So that's what this method tells. For the rows that have no match, I'm simply inserting. So that's what this command does. So it's very easy and straightforward form of this upsert logic. You can also have more control over merge into logic or upsert logic, where on top of this components that I already mentioned, you can specify extra condition for match. For example, Here I am using when match update clause as opposed to when match update all. And then I specify dictionary of columns from source and target side. So here I'm saying update the target column color with the source color column. And similarly for category, I'm updating with source category. You can also include condition keyword here to have even more control. So basically, instead of updating all the rows, you can specify which rows within the match you need to update. Insert part or append part of my merge into command is also slightly different. So instead of telling add everything that's not matching, I am here more specific, telling that fill the color column on target side with the color from source type and category from source from category side. All right, let me wrap up this transformation topic with really small but useful transformation called optimization. So what is optimization? When you are writing into your tables, Spark creates multiple versions of your files. And over time, your files get fragmented. So you will end up with lots of different files. Some of them may be small in size. Over time, this creates lots of overhead, especially when you are reading your tables. And it's good practice to optimize your file structure behind your tables. So optimization really means to take and merge some of these files to end up with fewer number of files, maybe bigger files which are better suited for performance. You can optimize your table structure using SQL syntax, but alternative approach, if you have already created Delta API object, you can simply use optimize command like this, which will optimize file structure of your table. All right, so far we have learned basics of pyspark. So we learned how to read data frames, write data frames, how to apply certain types of transformations. Now let's discuss some real-life scenarios, so some common data engineering challenges, and see how they can be addressed using pyspark methods. So I'm going to start by reading sales bronze tables that we have created earlier, and let's first talk about deduplication. So very often you receive data which contains some dirty row. There are different types of irregularities or dirty data. Some of them involves having extra rows or duplicate rows. When you are ingesting into your warehouse, in many cases you want to get rid of duplicates. Duplicates could be on entire row level, but in some cases it makes sense to talk about duplicates on subset of columns. So pyspark has methods to address both. So easiest way to deduplicate your rows is to apply distinct method. So here I am applying on the DFS data frame. If I display row counts from my original data frame as well as my target data frame, you will notice that I have got rid of many duplicates and my target data frame is much smaller. In my next command, the command 100, I am applying deduplication as well. However, in this case, I defined subset of columns based on which I need to do deduplication. So this is how my syntax would look like. So I'm going to use drop duplicates method. And as you may expect, my number of rows in my target data frame is significantly lower. Another common way of deduplicating data frames is using windowing functions that we have explored earlier. To do that, you can define groups of rows within your data set. and then number your rows within each group. So this is what my next transformation in command 101 does. So here I define window by product name, ordered by sales amount, and assign the result to row ID column, and then I filter out only rows which have row ID equals to 1. So this is the result. For each product, I had many different rows with different row IDs. However, by filtering out only one row, I can achieve deduplication effect. Let's talk about missing values. Missing values is another common data irregularity type where you would see empty values either in one or more columns. Sometimes you may see an entire row having empty values. So when you are ingesting into your lakehouse, it's desirable to clean up this missing values rows. Just like with deduplication, there are different ways of achieving that. So let me just read my data set. You will find another data file called sales data corrupted among the files supplied for this course. And if I display the data from this data source, you will notice that I have rows where either some columns are empty, so in this case client, or there are some rows where all the columns are pretty much empty. So these are, of course, different types of problems. So let's see how we can handle this kind of missing values. To handle missing values, you can apply an NA method on top of your data frame. And then there are different ways of applying NA. So you can use drop function or drop method on top of that, which will ensure that problematic rows are skipped in your target data frame. There are different ways of applying this drop command as well. So in the first example, which is in command 104, I am telling drop the rows where all the columns have missing values. So basically this will remove rows like this. So if I run this, you will see that the rows with all columns missing are gone. You can also be more specific in terms of which columns you care about in terms of missing value. So in this case, I am telling drop rows where this particular columns have missing values. So let's see the output data sets. So you can see that now I don't have any rows where product name and client names are empty. So to recap, we have explored a couple of ways to drop problematic rows altogether. But when you are handling missing values, dropping is not only solution. So sometimes you want to replace these missing values with something that makes more sense. So in command 106, I'm using NA object. However, I'm using fill method instead of drop to tell which column to replace with what. So basically this command tells replace anywhere product columns which have missing values with unknown values. You can specify more than one columns like that as part of dictionary. So in this case, I am telling replace all the null values in sales amount column with zeros. So let's take a look at the results. So here you can see how this replacement works. Okay, so earlier in this course we talked about auto-generated columns. So I mentioned that you can use Spark SQL DDLs, table create commands, to generate your tables. This approach could be very handy when generating time dimensions. So time dimensions, for those who don't know, are normally part of any data warehouse. So this kind of dimension tables will contain some useful date time related components like day of month or month number, month name, year number. These are normally extracted from date. Since date time dimensions contain lots of generic columns which can be calculated from date column, it makes sense to implement time dimensions as a create table, just like this. So I have one example here where I have date value column, which is the only column that I need to populate during ingestion. And then I have a number of auto-generated columns like month day or month number, month name, and I'm using SQL functions to auto-populate them. So you can see I'm using day of month. There are lots of different functions that are available within the pyspark SQL libraries. So let's run this. Okay, so once I have created this table, I can extract sales date from my source table. So in this case, it's sales bronze, and write it to that dimension table. So that's what I have here. So as you can see, I am populating only one column within this table. So let's run this and take a look at the results. As you can see, I have all the date-dependent columns auto-populated for me. So this is another useful technique when dealing with time dimensions. So the schema normalization is another common data engineering challenge. Let me explain this on the example of these two tables. So I have sales and the product information, which I have ingested earlier. Let's take a look at the structure of these data frames. So as you can see, my sales data contains product name alongside with some fact data. So things like quantity, sales amount, and so forth. My product data has all the properties related to product. So instead of ingesting this data as is, it makes sense to dedicate all the product related information in product table and include only link to that table within your fact tables. So in this case, we have product ID column, which is identity column for this table, for my product table. So ideally, I'd like to replace product name with corresponding product ID when I write into my fact. So let's see how we can do with pyspark. So in my command 112, I joined sales data frame with my product data frame on product name column. And I use left join because when you are joining fact to your dimensions, you may end up with some mismatch. So basically some product names which are in your fact tables may not present in your dimension table. So because of that, it's useful in many scenarios to use left join. And then I bring most of the columns from my fact table, but instead of bringing product name column from my fact table, I specify product ID, which is coming from product data frame. Notice that I have another transformation applied on top of this to address cases when I may have mismatch for certain products. So I'm using when functions, which we explored a little earlier, to check if the product ID from my product table is null. This is a case where I have mismatch scenario. And then I assign -1 as a key to these rows. Otherwise, I will just bring product ID as is. So as a result of this operation, my product ID column will be filled with fixed value of -1 for all rows where I cannot find a product name. So this is also called unknown dimension member. To have a complete solution, you would add one row in your dimension table with -1 as a key. And then by including -1 for mismatch rows in your fact table, you basically create full match between your fact and dimension tables. So I don't have mismatch in my data set, so I won't be able to demonstrate that part, but you can use this technique to address mismatch scenarios. Okay, time travel. One of the great features of Delta Lake technology is that it allows you to go back in time because Delta Lake use different versions of the file alongside with logging. So Delta Lake basically has its own logic mechanism which records any transformations that is happening to your data. And you can actually use this logging mechanism for many practical purposes. Easiest way to browse your table's history is to use describe history command. You can use either Spark SQL command for that, just like we discussed earlier, or you can use SQL magic for that. So this is how my table's history look like. So let's take a quick look. So important columns from time history versions. So I'll show you how you can use these versions to revert back in time. Timestamp is another column. So these two columns basically tell you at which point certain operations happen to your table. So here you have operation type. So for example, if I scroll down, I can see that my table was created at this point, which marked as version 0, and I can see the date, and then I can see a number of operations including update, delete, restore that apply to this table. Time history for table has lots of useful information that you can use in various ways, for either for auditing purposes or for some practical ETL needs. Let's use some of the practical applications. Once you know the history of your table, what you can do is just you can browse earlier versions of your rows using version as of clause, just like this. So here you have to specify version number. So this version number could be any of these versions. So for example, if I want to see how my data look like at this particular date and the version before restore operation happened, I can use this command. So I did not include display, of course. So display will allow me to browse this data. So this command is great for doing some analysis or auditing purposes. But there's another flavor of this command, which is called restore table, which actually changes the data in your table to its earlier version. So basically, you roll back your entire table to earlier versions. And it works similar way, so you have to specify version to which you want to revert. But use this command cautiously because it may impact your downstream processes. Okay, so let's talk about table clones, which is another tool in your practical tool set. Cloning allows you to quickly copy your table with or without data. So let me explain this. So because Delta Lake tables are based on data plus logs, you can create clone of your table by simply creating logs in another place, basically by copying your logs to another place. So that will allow you to create reference table or clone table. And from the moment you create the clone table, these two tables become independent. So anything that happens to your source table or target table will not affect the other party. So cloning can be shallow or deep clone. So the difference between them is that with deep cloning, you copy logs as well as data itself. Whereas with shallow copy, you only copy logs. So in many cases, shallow clones are okay. However, there are some scenarios when your source tables are vacuumed. Vacuum means that your past history has been removed. In these cases, your shallow clone table will be impacted, so you may have some reading problems. Whereas with deep cloning, you are not subject to this kind of problems. But both commands are a great way of creating quick copy of your tables. You can use cloning to create your backup of tables, or you can use it to create a just offline copy of your table, which allows you to do quick experimentation. The final topic that I'd like to cover in this tutorial is table partitions. So as I mentioned, Spark has distributed nature. So whenever you create tasks and data frames, Spark divides the data into multiple nodes that are part of your cluster. And then you have independent parallel computation. When you are writing to your target tables, you have control over how the data is written. So if you don't do anything, by default, all your data will be written into the same location, same folder. There will be many different parts of these files, depending on how many nodes and how many CPU cores you have. However, all the data will go into the same folder. In some cases, it makes sense to specify certain partitions within your data. You can achieve that by using partition by method and specifying column. So you can have more than one column specified as a partition. And by specifying partition by, your data in your target table will be written into different folders. So let me demonstrate that. So in this case, I am partitioned by product name. So if I run this, and let's find out location of my table. So this is a location. And if I use ls command, file system command, to browse the content of this folder, you can see that now I have different subfolders, one subfolder for each partition. One of the biggest advantages of having partitions is performance. So if you know that your data will frequently be queried based on certain columns, it makes sense to create partition on these columns. So in these examples, partitioning by product name ensures that whenever I have queries that are filtered based on product name, these queries are running much faster. And the reason they run faster is that Spark have partition skipping logic. Whenever Spark knows that the table has partition, it will go and find folders that match these partitions and so read only this relevant folder. So basically skip all other partitions, which can be a huge performance gain. All right, that's all I wanted to cover today. To recap, we learned how to read the right data frames. We also learned important column and the table level transformations. We explored Python to SQL interaction. So basically we learned running SQL queries within notebooks. We also explored some of the most common user-defined functions, which is important part of any data engineering task force. Finally, we have discussed number of data engineering challenges where I have provided some typical solutions using the transformation techniques that we have learned in the first part. I hope you enjoyed it, and if you did, please give my video a thumb up. Thank you, and I hope to see you in the next video.